Alright, fundamental theorem of algebra. I'll be impressed. Does anybody remember this?
No.
Oh yeah, yep, this is still all. It has to deal with how you can tell how many answers a polynomial equation has. If you solve those two problems we did yesterday, how many solutions did the first one have? Two. How many solutions did the second one have? Three.
It's the power.
Three, yep. The highest power you see in a polynomial tells you how many solutions it has. That's very basic terminology for the fundamental theorem of algebra. Okay? The degree of a polynomial is how many solutions it has.
The highest.
That is the degree. The degree is the highest,
Oh,
right?
yeah.
I mean, so yes, but you don't need to say that is what I'm getting.
Right,
You'll want to know your fundamental theorem of algebra. Okay? Put it in your own words. Should be pretty logical if you think about this. What's the degree of the polynomial x plus 2?
1.
1, right? Because the power on the x is 1. How many solutions does this have? 1, and that solution is negative 2. Okay? So here I started with a quadratic trinomial. I set it equal to 0, and I'm working on solving. Okay? Because this is raised to the power of 2, how many solutions is this going to have? 2. Well, you can tell now because I factored it for you. What are those two solutions going to be?
4.
4 and 3, right? Okay? And I could keep going. I could go to x cubed, and x to the 4th, and x to the 5th, and so on. Basically, whatever the highest power you see is, tells you how many solutions you're going to have. That is the fundamental theorem of algebra. Okay? Questions on that? So now let's get into finding those solutions. Solutions are also called roots or zeros, or you can also think of them as x-intercepts if they are real. So if I ask you to find the roots of a polynomial, I'm just asking you to find the solutions. And if I ask you to find the zeros of a polynomial, that's again asking you to find the solutions. Okay? Which you can look at a graph to help you to find all the real ones, because it's where the graph crosses the x-axis. Here's the line x minus 4, right here. Where does it cross the x-axis? At 4. So therefore we can call 4 the x-intercept. We can call 4 the root. We can call 4 the solution. We can call 4 the 0. All those things mean the same thing. Okay? Are you surprised it only has one solution? Shouldn't be, because what's the power on the x? 1, so it should have 1 0, should have 1 root, 1 solution, and so on. Okay? X squared minus 4x plus 1. What's the degree of this polynomial? 2, so we should expect to see 2 solutions. Do you see 2?
Yeah.
Yep. They don't look like they're very nice numbers. I could, put my little cursor over it and see what it is as a rounded decimal. It's probably not going to be very nice. Okay? But you definitely can see the 2 solutions, the 2 roots, the 2 zeros, the 2 x-intercepts. Okay? You shouldn't be surprised by that. The next one is an x cubed. Hard to see probably with the green there, but it crosses the x-axis here, goes up, hits it again here, and hits it again here. So you can see 3 zeros for that one, which again shouldn't surprise you because that's the degree of the polynomial. So a little visual idea as to why the fundamental theorem of algebra works. Okay on that? Does this also ring a bell? You've seen some of this before? Okay, maybe? Alright. Okay. Alright. Let's see. So how do we solve these polynomials? How do we find the roots? How do we find the zeros? How do we find the solutions, okay, of any polynomial? What's that? I'd set them equal to 0. Okay? The first thing I would probably do is set equal to 0 and solve. Or that's one way of doing it. Set equal to 0 and solve. Okay? Well, how do you solve? Well, lots of ways. Hopefully, and you'll love this one. Hopefully you can factor them. Because it's a lot better than all the other ways. Hopefully you can factor them. You may be able to get by using some square roots or cube roots. Not very often, but keep that in mind. That can work sometimes. Square roots, cube roots, etc. Here's one that I'm sure you've forgotten. Completing the square. Quadratic formula. Do you remember that one? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Synthetic or long division? Remember any of that?
Nope.
Put the number up in the box and do some adding and subtracting and multiplying and kind of that process. Synthetic division. Okay? And then, if you think about it, in those pictures I just showed you, how could you tell where the solutions were? Looked it up on the graph, so just see where the graph does what? Hits the x-axis, okay? So, graph and find x-intercepts. Okay, yeah? So those are all different ways that you can solve polynomials. You can graph it and just see where they cross the x-axis. Now, of course, I'm going to make it be a little more accurate than just a rounded decimal, but graphs will still help you. Okay? Alright. Any questions on this list? We'll do these. Alright. I'll show you. Okay? That's a good stopping point.